Okay, so let's talk about percent error. Percent error is the idea of how far off was your experimental value, because we're going to see this a lot, experimental value versus what the literature value is. You hear literature value, you may also hear accepted value. This is what is accepted by the scientific community, some valid, credible source. So I've come up with two just random numbers here. I have 13.2 milliliters would be our literature value or the accepted value, and the experimental value, okay, your experimental result, is going to be 11.0 milliliters. These are just made up numbers, but keep in mind that whenever you're looking at experimental value, it's always what you get in the lab, your result from doing the experiment, and the literature value is always what is on, on the box of a food label, let's say, or in the handbook of chemistry and physics, or on an MSDS. So it's a very accepted value. That's what we're looking for the accepted or the literature value. All right, so let's take a look. The equation is percent error is equal to experimental value minus lit value divided by literature value, all times 100. Okay, you multiply it by 100 to get the percent. So here we have our experimental value minus lit value. Let's plug those numbers in. 11.0 milliliters. We're going to make sure that we keep the units there. Literature value, 13.2 milliliters, all divided by our literature value, again, times 100. We'll run some quick math. We'll do, of course, our subtraction first. You end up with negative 2.2 milliliters. Okay, negative 2.2 milliliters. Keep in mind that when we're subtracting, our sig figs say we need the number of decimal place. There's only one decimal place in each of these, so we limit it to one decimal place for our answer, divided by 13.2 milliliters times 100. You plug that into your calculator, and what you end up with is negative 16.7%, 7% error. Okay. The negative, I don't really care about. The negative is fine. Things can be negative. 16.7%, but of course we have to recognize 2 sig figs, 3 sig figs, we're dividing, so we have to limit our answer to 2 sig figs. So 16.7 is a little bit too far. We're going to limit it to 17% error. Once again, the negative is okay. It just means that our experimental value happened to be smaller than our literature value. It happens all the time. I'm interested in the number, not so much the net positive or negative.